Hello, this is instructor Rick Powers from Western Technical College, Basic Statistics. Lesson 23, Sampling Distribution, Sample Proportion. In the previous lesson, we determined it is possible to find the shape of the graph for sample means. It is even possible to control that graph by changing the sample size. A similar process happens when we consider measuring proportions. You may be wondering, what is a proportion? I know how to find an average of a set of numbers, and I can get the standard deviation also. But what is a proportion? Actually, we've looked at this before, but it had a different name. So let's go over it. When we talked about the binomial distribution, we required a general probability, or a probability that applied to each observation. Another way to think of that idea would be to call it population proportion. That is the percent of all people in a certain category. Example, if 30% of all the people in Wisconsin have been to a water park, then the population proportion is 0.30. We write that as P is equal to 0.30. But if we take samples, then we won't always get 30% of the sample as having been to a water park. When we take a sample, let's say 200 people, and we find the number of successes, let's say 70, then our sample proportion would be 70 divided by 200, which is equal to 35%. In symbols, we use this. P hat is equal to X over N. It's called P hat, the letter P with a hat. Another way of describing this, we take the number of successes, X, and divide by the number of observations, N, to get the empirical probability, which is P hat. This is also called the sample proportion. So then, one number is the general probability, or the population proportion, with the symbol P. Another number is the empirical probability, or the sample proportion, with the symbol P hat. Just as before, hopefully it makes sense that the sample proportion will not always be equal to the population proportion, but it will have sampling variation. And just as in the previous lesson, if the sample size is large enough, then the distribution of the sample proportion will be bell-shaped. However, the requirement is quite different for proportions. It's not n greater than 30, but it is the same as given previously. N times p times 1 minus p is greater than 10. Practically speaking, we often need a few hundred observations in order to get bell-shaped results. So here are the equations for the distribution of the sample proportion. The mean of the sampling distribution of P hat is mu sub P hat, which is equal to P, the population proportion. The standard deviation of the sampling distribution of P hat is sigma sub P hat, which equals the square root of P times 1 minus P divided by N. Note that we can control the variation in our samples by controlling the sample size. Larger samples will make our sample proportions more accurate. Side note, by using algebra, we can derive these equations from the similar equations of the binomial distribution. Once again, we have the tools we can use. If we know the population proportion and the sample size, then we can find the mean and standard deviation for the distribution of the sample proportion. And we can use all the technology of the normal distribution to find what to expect from our samples. End of lesson 23.